Hello, I personally welcome you as you land on this channel, and of course as you begin to watch the first video on the JAMB Crash Course series. The Crash Course series is the video series for JAMB students where I personally would be attempting to explain important JAMB topics in about 10 minutes. And for today we would be having physics, and the topic for discussion is dimensional analysis. At the end of this video, you should be able to solve the questions in the comment section. Very important, and submit them using the link you are going to see. So without wasting much time, let's get started. Physics is an experimental subject, which means that there is no way you can claim to study physics very well without having to carry out one experiment or the other. Okay, now whenever you want to carry out one experiment or the other in physics, there is something you must always do. And what is that? Measurement. You must always measure one thing or the other during any experiment. What do we measure during experiments? We measure what we call the physical quantity. A physical quantity is a property of a particular material that can be measured. Okay, I love to be very practical whenever I am explaining. Look at this particular stuff, for instance. What is this now? This is a stone. I mean now, okay. Now you would agree with me that this particular stone has different properties. For instance, I can start looking at its color. Okay, it is kind of reddish brown. It is a clayey stone, kind of. That is its color. It has a color. Okay. If you look at this stone very well again, you would observe another property of this stone. And what is that? It is porous. It contains pores here and there. So porosity is a property, a feature of this very stone. Okay, apart from porosity, another property of this stone could be its mass. It has some matter. It is kind of heavy. Okay, so this stone is matter. It has some mass within it. It is kind of heavy. If I place it on a weighing scale now, it would give me a particular value, probably 20 kg or the likes. So what is the point? The point is that this particular stone has different properties. However, not all properties of this stone can be measured. I can't just measure the porosity of this stone. I can't measure its color, but I can measure its mass. That mass itself, which is measurable, which is a measurable property of this stone, is what we call what? Physical quantities. So the physical quantity of a particular material are what? Are the properties of that material which are measurable. Fine, we now have three types of quantities basically. We have what we call the fundamental quantities, the derived quantities, and what? The supplementary quantities. Okay, look at your screen now. Examples of the fundamental quantities are, you can see mass, you can see length, you can see time, you can see dynamic temperature, you can see electric current, amount of a substance, and luminous intensity. These 7 quantities here, physical quantities, are the fundamental ones. They do not depend on any other quantity. They are elementary, they are basic. Okay, now we also have derived quantities like velocity, momentum, force, pressure, just name them. Okay, then we have what we call the supplementary quantities. That might ask you, which of the following is a supplementary quantity? Examples of supplementary quantities are just one. We have what we call the plane angle. We have what? The solid angle. The unit for the plane angle is the radians, and the unit for the solid angle is the steradians. Okay, understood. Let's now move to the next one. See, when we talk about dimension in physics, the dimension of a quantity is how that quantity relates to the fundamental quantities, like the relation between that quantity and what? The other fundamental quantities. So if I ask you now to look or to determine the dimension for pressure, I am asking you to look or to tell me how that pressure itself is related to what? The fundamental quantities of mass, length, time, and what? And the like. In your UTME, that might ask you to look for the dimension for so and so quantity. You might be asked to look for the dimension for force, the dimension for pressure, the dimension for just any other word, derived quantities. See, it's very easy. Just calm down. For you to accurately define or determine the dimension of a quantity, you just need 2 steps. The first step you need is to, number 1, write out the derived unit. The derived unit of that particular what? Quantity. Okay, and the number 2 thing you need to do is to do what? Compare that unit to the MLTIK. M means mass, L means length, T means time, I means electric current, and K means Kelvin. Let's take some examples because I love to be very practical whenever I'm teaching. Okay, imagine that you see this particular simple question in your JAMB now, UTME, and they are now asking that what is the dimension for velocity? Very simple question, very easy. What is the first step? The first step is that number 1, you just look for the derived unit. Finish. Okay, and what is the derived unit for velocity? Meters per second. You are done with the first step. What is the second step now? Look out for how that meters per second relates to the standard MLTIK. What then do we have for velocity? Velocity is meters per second, okay? The m there is meters, the s there is seconds. Meters is the unit for length, so you bring out the L, the capital letter L, length, okay? And the s there, seconds, is a unit for time, so you bring out the T there, capital letter T. But that second is carrying -1, as you can see. You just put the -1 there. So what then is the dimension for velocity? Very easy. LT raised to the power of -1. JAMB might even ask you to determine the dimension for acceleration. Very straight to the point. What do? Number one, you determine the derived unit for acceleration. What is the derived unit for acceleration? Meters per second square. Fine. So you write it out, meters per second square. Then you now compare it with that MLTIK. Okay. Now meters is the unit for length. So you write the length out to show that it is representing or it is coming from meters, capital letter L. Then that particular second square, second is the unit for time. You bring out the time, capital letter T. Then you are good to go. But then before you are good to go, you put that -2 on top because it is s raised to the power of -2. So you must also put it as what? T raised to the power of -2. Therefore, I can submit to you that what? The dimension for acceleration is LT raised to the power of -2. Fine. Okay. I can just keep thinking. That might even ask you to determine the dimension for force. Force is what? Mass of acceleration. Now, what is the unit of mass? Kilogram. Acceleration, meters per second square. So force is the derived unit for force. Derived unit, I said. The derived unit for force is that what? Kilogram meter per second square. To now get the actual dimension for force now, I would have to compare this kilogram meter per second square to the MLTIK. Okay, let's take them after the other. The kilogram here is for mass. You write the mass out, capital letter M. The meters there is for length. You write the length out, capital letter L. And the second raised to the power of -2 is what? Is for time. You write it out, T raised to the power of -2. So what do you have now? MLT raised to the power of -2. That's the dimension for force. This juncture, I need to point out something, and that is the fact that that might also give you a question that would not only involve you to use MLT, but would also involve you to use MLTI, like probably current or what, or temperature. Okay, let's look at an example to illustrate this better. That might ask you to calculate or to determine the dimension for EMF. EMF means electromotive force. Okay, now if you want to determine the dimensions for EMF now, you just take the EMF to be voltage. EMF has the same dimension as voltage, okay? There is no clear distinction between EMF and voltage. The only difference between EMF and voltage is that the EMF of a cell is the voltage of that cell before the cell is connected to batteries and the lights, okay? But they both have the same dimension. So just look for the dimension of voltage, and the dimension for voltage would be the same thing as what? The dimension for EMF. Okay, we all know that voltage is equals to work over charge. The voltage is the work done in moving a charge from a point to another point, okay? Work done per unit charge. So voltage equals to what? W over Q. Work done over charge. Okay. Now work done itself is force times distance, and charge itself is what? Current times time. So work done is equals to what? Force times distance over Q. Q is what? Current times time. Okay. So you look for the dimension of force times distance, and you look for the dimension of what? IT, then you are good to go. Let's continue. Force itself, the dimension of force as we have already established is what? MLT raised to the power of -2. Okay, times what else? You have the length, the distance. The distance is for length also. So the distance is a measure of what? Length. So you just write the capital letter L. So we have for work MLT raised to the power of -2 times distance times length for work done alone. Let's come to the denominator also. For the denominator we have what? We have charge. And charge is equal to what? Current times time, IT. Okay, now you see, I is already a fundamental quantity. Current is already a fundamental quantity. It does not depend on any other quantity. So you just write the I the way it appears like that. Current. Okay, the change of now representing it with something else. I is current. You write out the current like that, and the time of course is time. You write the denominator to be what? IT. You leave the denominator as what? IT. Are you with me now? Okay. Now, if you do not get this, you play the video. So by the time you do the mathematics of the numerator, you will end up with ML squared T raised to the power of -2. And then divided by IT. If you do the normal mathematics from indices now, you end up having what? ML squared, then T raised by -3 I inverse. Stopping there for today. I hope you really learned a lot from dimensional analysis. Check in the comment section. You would see a list of 10 questions there. Make sure you attempt them. And after attempting the questions, click on that link to submit them and the answers will be provided to you automatically. You might think that you've now understood dimensions. No. For you to be sure that you now understand it, for you to be sure that it's not just an illusion of mastery, make sure you solve questions. Your score will determine how well you now understand dimension. I think you understand it, but in the end, you might actually not understand. It might be an illusion. So thank you very much for watching. We'll see in the next video next Sunday 5 p.m. as usual. But before then, make sure you subscribe and like this video. And also let me see, is there any topic you'd want me to make a video on? Probably my self-screen videos. I will of course make the video on that particular topic. We'll see in the next video.